Hi everyone, we're on page 22. This is day 7. It's probably going to feel a little repetitive from day 6, and that's okay. Hopefully, if you got it, it will be easy, and if not, this should clear it up. All right, number 1, graph y equals absolute value of x. So now we're doing another function. We had done x squared and we had done square root of x on day 6. Absolute value of x, there's 2 ways to get there. You can get there using the catalog. It'll be the first thing in the catalog. ABS, or you can get there doing math over to number, absolute value. They're both pretty easy to get to. What I do want to do is go to y equals first and then put in absolute value. Put an x right inside there. We're looking at just plain old absolute value of x. I'm going to the table. Absolute value of x does have a turning point, just like a parabola. So I'm looking to see that same idea. I went up one too far. Now you can see the symmetry in the y column here. So I'm going to make a table just like I would for a parabola. I'm just going to do a few values here. At -2, we're at 2. At -1, we're at 1, 0, 1, 2. And I'm going to plot those. And I'm going to use just like a sheet of paper to kind of be my straight edge. How come I didn't use a straight edge in the last lesson, but I am now? Because a parabola is curved, so I just kind of have to eyeball that. An absolute value graph is made up of straight lines, a straight line here, a straight line there. So that's why I used a straight edge. Okay, so this is our regular old y equals absolute value of x. It's our parent function. No shifts, no movements on it. It's just right at the origin. The vertex is right at the origin. How are the graphs of absolute value of x and y equals x squared related? They both have a turning point. Another name for a turning point is a vertex. They're both symmetric. You could take them and fold them on each other. The parent functions specifically are symmetric with the y-axis. What's the domain? The domain, just like your regular x squared, just like all your parabolas, is -infinity to infinity. What's the range? The range is 0 included to infinity. Lowest it goes is 0, it is included, it goes up to infinity. Okay, based on lesson 6, we should know what's going to happen here. This lesson is just reiterating. If it's on the inside, it's moving it left and right. And it's the opposite of what it seems, so it's going to go left too. That's what should be happening. Coming back to y equals, I can just go over and it'll stay inside here. I want to make sure I'm hitting, hang on, is it plus? Just kidding. Okay, so plus 2. Y equals absolute value of x plus 2. I'm going to go to the table and find that turning point again. Now the turning point is at -2, 0. So I'm just going to write a couple of points around that. So I'm going to go from -4, -4, 2, -3, 1, -2, 0, -1, 1, and 0, 2. Plotting those points, 1, 2, 3, 4, 1, 2. And again, just using my straight edge. And just like knowing these facts, and there's a lot more to, graphing, but sometimes when a student is in class and you're telling everybody, okay, now graph this, and somebody raises their hand, oh, mine doesn't look like that. And the teacher might not even look, and they're like, oh, well, what does yours look like? Be like, oh, mine's at 0, 0. And the teacher would be like, well, go back into y equals. Yours doesn't have x plus 2 in it. And then a lot of times the students are amazed, like, how'd you know that? Well, it just comes from knowing these rules. I know that if you graph an absolute value graph and your turning point's at the origin, I know you have no horizontal shift on it. You didn't have a +2 in the middle because a +2 in the middle moves it left 2. Okay, so how are the graphs of x and x plus 2 related? Same shape. We just shifted it. We still have that absolute value graph. How are they different? They have different turning points. I'm going to just abbreviate there. This guy has a turning point of 0, 0. This guy has a turning point of -2, 0, moved left 2. What's the domain? The domain, still -infinity to infinity. Just like when I move a parabola around, it still goes left and right forever. My range here, since I didn't move it up or down, my range actually is the same as well. My range is 0 included to infinity. So that's actually another thing they have in common. Domain and range are also in common. Okay, exercise 3. Now, this guy doesn't have anything in the middle, so I know it's not going to be shifted left or right. Going back to y equals, and I'll clear that out. And just once again, I'm going to go to math over to number. The first thing in there is ABS, and it might still say ABS. Depending on how old your calculator is, it might not give you the absolute value lines. That's fine. Okay, it says ABS in parentheses. You just put whatever's in the parentheses in it. In this case, only the x would go in the parentheses. Notice I moved over. I'm looking at a +3. So the +3 should be on the outside. I'm going to go to my table. And just like a parabola, I'm looking for a turning point. There it is at 0, 3. So I'm making a table. For this one, I'm going to pick a few points around that turning point again. So -2, 5 is in my table, -1, 4, 0, 3, that's the turning point I pointed out, 1, 4, 2, 5. So going to -2, going up to 5, 1, 2, 3, oh, my eyes are deceiving me, hang on. -2, 1, 2, 3, 4, 5. There's a point. -1 is at 4, 0, 3. Okay, so going back to the original that I graphed on this page, what happened from exercise 1 to exercise 3 was shifted up 3. Okay, how are these graphs related? Same shape again. And these guys will have the same domain, but they won't have the same range. We'll get there in part F. How are the graphs of y equals absolute value of x and absolute value of x plus 3 different? Again, they have different turning points. The turning point for our original was 0, 0. This turning point 0, 3, or vertex. It was shifted up 3. I could write that. Back to this one, I can say shifted left 2. What is the domain? Well, the domain of this guy, again, just like a parabola, it doesn't matter where I move it, it still goes left and right forever, so it's -infinity to infinity. The range is affected. This one doesn't go all the way down to 0. The lowest y value, range is y values, it hits is 3. That's the lowest y value. And then it goes up forever, so to infinity. Okay. Next page, we're going to kind of summarize the stuff I talked about in lesson 6 and 7 here in this rules for writing equations with translations. When the graph is shifted left or right, the x variable is affected in the equation. You add or subtract to this number on the inside. left or right shifts always use the opposite sign of the shifted number on the inside. So I'm just going to put a little example in here. If I were talking about the graph of y equals x plus 2 close parentheses squared, that would shift y equals x squared left 2. That's what that would do to it. It would shift it left 2. When the graph is shifted up or down, the y variable is changed in the equation by just adding or subtracting the shifted number to the outside. So it's at the end of the equation. So an example for this one would be y equals x squared. So I'm done squaring it. I'm not adding or subtracting anything right to the x. Just at the end, if I do minus 2, that would shift y equals x squared down 2. And we've got 3 different examples. These are really good examples here at the bottom because we've got 3 different kinds of functions. We'll talk about that as we go. And we're going to have to state where the vertex is. I'm actually not going to go to my calculator. You would definitely want to check in your calculator, but I'm just going to kind of go off of the rules that we talked about and make a little sketch down here. And after we have our sketch, then we'll state what the vertex, domain, and range are. Okay, so looking at A, I know it's a parabola. How do I know it's a parabola? I see x squared. That's how I know it's a parabola. I don't see anything added or subtracted to the x. I do see a number subtracted at the end, so that's going to be a downward shift. I'm going to start with just what our regular parent function parabola looks like. It looks like that. This is telling me to shift that graph down 5. So when I take that parabola, 1, 2, 3, 4, 5, and I shift it down 5, that's the only shift on it, that's what it looks like. Now I can see that the vertex is at 0, -5. My domain from the original is not affected, -infinity to infinity. My range is, the lowest this goes is -5. Highest it goes up forever, so infinity. Okay, now I kind of already alluded to this by saying we had 3 different functions, but this would be a mistake. I'll use a separate sheet. I'll use my little straight edge sheet. If somebody was like, oh, I got it. Okay, we're going right 6, up 4. And I'd be like, awesome. And then they went like this. Right 6, up 4. What are they doing wrong? This is not talking about a parabola anymore. So the important thing, another important thing that I haven't really been stressing throughout, but I'm stressing it right now, is that we need to know what shape we're talking about. This is talking about an absolute value graph, which looks like that. Boop, boop. Wow, that was a bad picture. I'll draw that again. Now, might get lucky and your domain and range answers could be right because these shapes are obviously so similar. But if it asks you to draw it, or you had to pick it out of a multiple choice question or something like that, or if there's reasons beyond what I can think of off the top of my head where you need to know what it looks like. Okay, so I'm going to take this graph and I'm going to shift it right 6. Why am I going right 6? Because that's on the inside, and I do the opposite, right 6. I'm going to go up 4 because this is on the outside. It affects the y value. It's on the outside. Right 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Boop. So my new vertex is 6, 4. My domain still -infinity to infinity. My range, the lowest this goes is a y value of 4. Goes up forever to infinity. Okay, the last one, now I've already brought this up, but we can't assume that this is a parabola. A lot of people just always assume parabola because that's our most familiar one and we use that one a lot. This is not an absolute value graph. This is a square root graph, which is totally different. A square root graph, the regular old y equals x square root of x looks like that. It's that half a sideways parabola. Now, try and answer this before I do. What is happening? What are the shifts on that graph to get h of x? We are going to move left 1 down 7. How do I know it's left 1? Inside, do the opposite. Outside, do what it tells you to do, down 7. Left 1, down 7. 1, 2, 3, 4, 5, 6, 7. So now just note I'm labeling this as I move around. Still looks like that, so I'm just trying to copy and paste the same thing I had, but just moving it around. Now that key point is the end point, and it moved from 0, 0 now to -1, -7. Domain, the domain was never infinity, negative infinity to infinity. My original domain was 0 to infinity. Now it moved left 1, so my new domain furthest left this goes is -1, and it goes right forever, so it goes to infinity. Range, the lowest it goes is -7, and it goes up forever, so it's at positive infinity. Okay, hopefully that helps with homework 7. If you have any questions on it, just feel free to email your teacher. All right, bye everyone.